Hello, honorables. Thank you so much for your questions about Fermat's last theorem solved by binomial. And they are asking about the G and K. It is not zero. Okay, polynomial or came from the binomial always has interior between first term and last term. There's interior. That interior, any term, never be a zero. Because when I tell 5 to the 3 equal 125, if some terms is zero in binomial, that means 5 to the 3 will be not equal to 125. And this is wrong. This is the proof that binomial telling you, not me, binomial telling you interior terms never be zero. And let me show you the fact. I name it Taha's binomial fact. Taha, okay, I am. You see this star? This is binomial telling you this, not me. Any binomial theorem, x plus y all to the n, guarantees that yields non-zero integer. Thereby, let me put my glasses to read. Intermediate terms, these terms remain part of the final polynomial less than x plus y. That means the interior is g. That g always less than the x plus y to the n, which is equal c to the n, for example. Okay? G never be zero. When you have two terms like this, when n is even, okay, then the first one positive and the last one also positive when n is even. But when you have subtraction and n odd, this exponent n odd, when it's odd, this b will be a negative. That's why even AI to AI, artificial intelligence, they told this is not polynomial. Your question about the Fermat don't relate it to the binomial. This is my proof. You are seeing this is negative. Okay, but there's a solution for that. What's that solution? Go ahead and add zero here. Nothing will happen. You added zero. That zero is b to the n minus b to the n. And you keep the positive one here. Okay, this negative and negative becomes 2 negative. Negative 2 b to the n. Or k minus 2 b to, this one is now g. This g, the middle terms between a to the n, b to the n, never be zero. Who told that? Binomial. Then, when this is not zero, negative or positive? Somebody told me g is negative 8. Nothing wrong with that. Somebody will tell me g is positive 8. It's okay. But the important is g is not zero. When g is not zero, that means when I go to Fermat's last theorem, I will tell, okay, depend on Taha's fact, a to the n plus b to the n not equal c to the n. I hope this is the answer for artificial intelligence. Two programs told me no. I told yes. And this is my proof. You saw it. If you have question about my proof, you can let me know, please. And also 4 people asked me that prove, go ahead, prove g is zero. And somebody telling me, giving me example and told me negative 8g is okay. Why not? G, important thing is not 0. Negative or positive, but not 0. Okay. Thank you so much. Bye-bye. I put this on YouTube, please, on x.com, also, and Google document. Okay, in order you see this Taha's binomial fact. Thank you. Bye-bye.